today we work with circles and what we call central angles and arcs. Maybe you've heard of one of or two of those. I can't remember if we've talked things like central angles. It's a pretty simple concept. If I have a circle and I start dividing it into fractions, maybe, well, first we should decide where the center is. And then, if I draw a line to one side and maybe I make it into fourths, okay? If that's truly a quarter of my circle, then what would be true about the angle I've made? It is a quarter of the total number of degrees that go in a circle. It's also true, as you can tell, that's a 90-degree angle. Because when you cut a circle, which is 360 degrees, into a fourth, you get 90. Right? Now, if they say draw a circle with central angles, that's what this is called. This is a central angle. But if they want it divided into thirds evenly, okay, then we need to decide what angle measure would be a third of a circle. Well, I can't just draw it. I was about to, but I can't. I need to decide 360 degrees, that's the full circle, that's all the way around, divided by 3, and that happens to be 120 degrees. So I get out a protractor and I measure what is 120 degrees, and let's pretend I'm using a protractor right now, and it looks like that. That's 120 degrees. Okay? So with a protractor, I'd be able to get this exact instead of just guessing what a third is. I'm using a protractor, I'm using a protractor, I'm using a protractor. And each of these, according to the protractor, should be 120 degrees. Might take a little practice doing that with your protractor because we're still somewhat novices with a protractor. But it's hard for me to show that on here unless I used other technology, which I don't have. Now, the court of a playground is painted on the blacktop. Court of a playground game. The court is formed by a circle. No surprise there. With two intersecting diameters. We know what a diameter is. Now, they form four central angles, one of which is only 50. Alright, so if we have intersecting diameters. One angle is going to be 50 degrees. That means another one's going to end up being 50 because we know that about lines, which means the other two have to each be combined 260 or 130 and 130. So you can always just start with a line, right? We have a diameter. Let's go like this. All right. Now we need to make at least one angle that's 50 degrees. Okay, so I'm maybe measuring out where 50 degrees is from here. And I can go either side. I'm going to stay symmetrical. And I'm going to pretend I was using a protractor kind of upside down here. And I mark off of this center diameter that here is 50. Okay? Then I take my ruler and I start from there so that I know I have a 50 degree angle. Actually, I should probably do something else. I should mark 50 on the other side. On the opposite side, right here. Okay, I've measured. Now I'm ready. Connect my 50s so that I have two intersecting diameters that each measure 50 degrees. Now this, as I was saying, is probably 130 and 130. And it said find the measures of the other angles, so make sure you're always doing the whole problem. A little wordy and hard to understand, but Now that you've seen it, hopefully it does make sense. Another term for us to know is arc. The arc is the curved part you've just cut off. Right here is the arc. This part of the circle. This is the arc of this angle right here. And the arc's degrees match the angle degrees. So we would say that this arc is 130 degrees. And this arc is 50 and so on. And that's the symbol for an arc, kind of fun over like if you start marking them like this one. Arc AD right here. It asks what is its measure? Well, we just learned it's the same as the central angle, so it's 60. That's easy. Let's keep going. What fraction of the circumference is the arc intercepted by A, B, D? Well, 360 is the full degrees in a circle. I think we know that by now. So we do 60 into 360. And that is 1/6 of the total circumference. And what's fun now is that once you've thought that through, and we know the radius is 6, we have to know a measure of the circle somewhere, then we can decide how long is this, even though that's really hard to do with a ruler, because we know it's 1/6 of the total circumference. So we just do 1/6 times diameter times pi, right? And that'll end up giving you your answer. So we can actually measure arcs by knowing degrees. Fun. All right. Why don't you do all the practice?